graphing software to continue to analyze even and odd degree polynomials. There'll be a link in the profile where you can go, or the description, so you can go straight to the Desmo site and practice along with exactly the functions that I have written. We're going to look at in behavior now. This is part 3, in behavior. What do I mean by in behavior? Well, before you have done anything else, you need to title this as even and odd degree polynomials part 3, end behavior. This stuff right here, end behavior. Once you've done that, then you can unpause the video and continue. Alright, if you've actually done that, that means you can now continue. Continuing means that you're actually going to write all of these things down here. So everything down here, I want you to write down before you do anything else. Great. Now that you have all of this written down, each of these, we can talk about in behavior at last. In behavior is exactly what happens, and you can see it here, which you've already written, as the x values. So as the x values of a function go toward infinity, this is me going toward infinity, notice the arrow going toward infinity, or toward negative infinity. We're going to talk about even degree polynomials first. Even degree polynomials only have 2 types of in behavior, and we've already hinted at actually both types. So the first type is if I had a positive leading coefficient. A positive leading coefficient. The second type is if I have a negative leading coefficient. I'll be really clear what that is in just a moment. Make sure you've taken now all of this information down that you can see here. So everything here, pause the video, and then go ahead and press play. Have you actually recorded all that stuff? Then don't press play. Great, okay, now we can go ahead and get started. Positive leading coefficient. Well, look, the first thing that I need to do every time is find out what degree it is. So I look over here and I see this is a degree. Well, there's 0, 2, 4. Okay, so degree 4. Great. Positive leading coefficient says, hey, look at that largest term. Look at the degree determining term. What is it? Well, it's 5x to the 4th. Okay. Is 5x to the 4th positive or negative? Yeah, it's positive. 5x to the 4th is positive. Right. That means it's a positive leading coefficient. That's all that means. Pause the video and write down that simple summary. Great. Now that you've done that, no, you need to actually do that. We can move on to this next example. So in this next example I have 1, 2, 3, 4. So it's an even degree, it's degree 4. And then again, what is this term right here? That's right, it's, no, is it positive or negative? That's right, it's positive, it's positive 2. So both of these have positive leading coefficients. This is either example. I have standard form here, factored form there. They're both positive leading coefficients, and this is what they look like. So, in other words, as I get further and further and further and further away from the origin, and as my 2 functions are going toward infinity, as this function is going toward infinity, what happens on this right side? Well, as I go toward infinity, the function goes towards infinity up here. And then let's look at the left side of the graph. On the left side of the graph, what's happening? Well, as my x values go toward negative infinity, so notice where the arrow's doing, as I go toward a negative infinity, what's happening to the y values? They're going up, right? They're going to positive infinity. So make that summary down. As x goes to infinity, you can write an arrow. That's what x goes to means. So as x goes to infinity, f of x goes to positive infinity. As x goes to a negative infinity, f of x also goes to infinity. I'm going to show you a much simpler summary in just a moment, but for now, I want you to write that down. So pause the video, rewind it as many times as you need to write those exact specific things. Alright, so that's in general what an even degree positive leading coefficient polynomial looks like. And let me just trace this again. Guess what it looks like? See my arrow right here? That's right. It goes like this. Bloop. That's what it looks like. That's all that stuff that we just said means, that it has this shape. Now we're going to look at the negative leading coefficient. You can probably already guess the shape. So it's the same two functions. The difference is I've just made it negative. So this is degree 4. It's a negative 5x to the 4th. This one here is degree 4, 2, 3, 4, but it's a negative 2 now. So this is a negative leading coefficient. It's going to give us a different result. Let's see what it is. That's right. The only thing that changes is instead of going up like this with a positive, it's going to go down. So as x goes to positive infinity, as x goes to positive infinity, f of x goes to a negative infinity. F of x goes to a negative infinity. As x goes to a negative infinity, the x values go to a negative infinity, f of x goes to a negative infinity. So the fancy way of saying it is the stuff I just said. Pause the video, take that down. Milton, I need you to actually pause the video and take that down. Bianca, you too. Other Bianca, you too. All right. Now, all that really means is that a negative even degree polynomial, negative leading coefficient, even degree, all it really means is it's going to start here, and it's going to go like that. It's going to have that shape. That's all we mean by that stuff that we just said. Okay, pause the video, take all that down, do nothing else until then. Now this is something that I want you to actually just sketch. Notice this is even degree polynomials, so you'll draw a different one for odd degree polynomials. The blue represents positive leading coefficients. It means it's going to go like this, and it's going to go like this. That's all we mean by end behavior. We don't care about what's happening in the middle of the graph at all. We don't care about it. Yet, for end behavior, we just care about what's happening on the ends of the graph. So for even degree polynomials, and it's positive, it looks like this blue stuff here. Good. For negative coefficients, for negative even degree polynomials, it looks like this pink stuff here. I just want you to sketch that. Make sure you write all these things. Positive here, negative here, and that you know what the positive is doing, and you know what the negative is doing. Call it end behavior, and you're done. When you've sketched that, we can move on to the odd degree. Okay, there's a lot more writing, so we're going to talk about odd degree polynomials. They also only have two types of end behavior. Again, type 1, positive leading coefficient. Type 2, negative leading coefficient. Do nothing until you've copied all of this stuff down. You need to copy this down so that you understand what this refers to. When you've done that, you can move on. Have you actually done that? I need you to actually do that. Nemo, have you done that? Okay. Once you've done that, you can move on. Okay, we're going to look at what does a positive leading coefficient actually look like. So we can do nothing until I know that for sure this is an odd degree polynomial. So I look at this polynomial quickly. I see there's no x here, x to the 2, x to the 5. 5 is biggest, so therefore it's odd, degree 5. And this number, the 72, that's positive, right? So it's a positive odd degree polynomial. And then I look over here at this next one, that's an x squared. Remember, this is x squared times x, that's x cubed. That's odd also. And this 3, it's, right, this is 3, is positive. So let's click plot and see what they look like. So it looks just like our parent function x cubed. Pause the video, write exactly that. Now that you've written exactly that, unpause the video, we'll move on. And what do I mean by just like x cubed? That means as I go towards a negative infinity, as the x values go toward a negative infinity, the y values go toward a negative infinity. As the x values go toward positive infinity, the y values, the f of x values go toward positive infinity. Take that down. Only after you take that down can you unpause it. Okay, you've taken that down. So what do I basically mean? I basically mean that if it's a positive leading coefficient of an odd degree polynomial, which is a really fancy way of saying one of these guys, it's going to look like this. See my arrow? It's going to start here, and then it's going to eventually end up over here, like way up here. It's going to start down here, and It's going to end up over here. That's what it looks like. That's type 1. Okay, pause the video, and we'll look at type 2 in just a moment. Okay, we're ready to look at type 2. This means that you know what type 1 looks like and you've summarized that. You haven't? Okay, well then stop and do that. You have? Okay, let's keep going. Type 2, negative leading coefficient. In other words, look, this is the same thing that I had up here. This is the same that I had up here. The only thing I did differently was I made it negative. So let's see what they look like. Okay, some of you guys get this confused, which is just another reason to make sure you have absolutely memorized the parent functions. But let me summarize for you. This is the words you'll need to write. So take these words down exactly. As x goes toward a negative infinity, as x goes toward a negative infinity, f of x goes toward positive infinity. F of x goes toward positive infinity. As x goes towards positive infinity, as x goes towards positive infinity, f of x goes towards a negative infinity, f of x goes toward a negative infinity. That's what you need to take down technically, and then I'll summarize it for you in just a moment. But write that down first. Okay, now that you've done that, I'll tell you what this actually means. So if you have a negative leading coefficient, and it's an odd degree, which is these two things right here, the things that I've graphed, it basically means just this. Look at my arrow. See the arrow? It means I'm starting here, somewhere over here, and I'm ending somewhere over here. So I'm going from over here to over here. That's all that means, period. That's it. Okay, pause the video. So just like for even degree polynomials, I made a summary chart for odd degree polynomials. In this case, if I have a negative leading coefficient, it's going to start up on this top left and go to the bottom right. It's going to start in the top left and go to the bottom right. The negative is the pink. If I have a positive leading coefficient, it starts in the bottom left or in quadrant 4, and it goes up to quadrant 1 in the top right. And that's what all odd degree polynomials behave like. They either have the negative leading coefficient and look like this, or they have a positive leading coefficient and look like this. Make sure that you've sketched exactly this and that you've differentiated what the positive is to. So make sure that it's very clear that this is a positive leading coefficient, this stuff is, and these are negative leading coefficients. Once you've done that, we'll move on to the practice where you're going to actually do just this. So listen to this. You're all only going to do is sketch these arrows here. Nothing else. None of this stuff. You're just going to draw these arrows. Where do these little arrows go? That's it. Pause the video, take down this sketch, and then when you're ready to move on to practice, unpause the video. If you're watching the video, it means you're ready to move on to practice. Notice that it says sketch each of the polynomials in behavior. Remember, that's just the arrows. Do the arrows go here and here? Or do they go here and here? Or do they go here and here? Or here and here? Those are only 4 options for any of these. First, what you need to do is make sure that you recognize them. So you're going to pause the video in just a moment. You're going to take down all of these functions. All of these. You're going to take all of these polynomials down. Then you're going to say exactly what degree it is. In other words, like the one that I'm on right now, c of x, it's degree 5, which means it's odd. You're going to decide whether it's positive or negative leading coefficient. In this example, it's degree 5, and the 5, x to the 5 is attached to negative 4. Negative 4 is negative, so it's a negative leading coefficient. So those are the things you're going to do first. After you've done that, then you'll go through and sketch each of these. No, not like the whole graph. Again, only the bin in behavior. So in this case, it's an odd and it's negative, so you would do this. You would draw an arrow here and then draw an arrow here. So pause the video, go through each one of these and practice, and then we'll look at them in just a moment together. You're only moving on to this part if you've actually written all of these down, you've labeled them what the degree is, if it's even or odd, and you're ready to check your sketches. So you've sketched all of these at this point. If you have not done that, then you've got to pause and do that, and then you can move on. Okay, so I'm going to go through them quickly. A is an odd degree, degree 3, and it's a positive leading coefficient. And the arrows look like that, here and here. B is an even degree polynomial, positive leading coefficient. Looks like this. So the arrows go here and here. C is one we've already gone over. It's a negative odd degree of degree 5, and the arrows go here and here. D. D is an even degree, look at that, x to the 10, and that's a positive leading coefficient, so the arrows go here and here, just like the graph looks. F of x, it's an odd degree, degree 3, positive leading coefficient, so the arrow goes here and here. G of x is degree 5, and 4 is positive, so it's a positive odd degree, so the arrows go here and here. H, it is degree 3, 4, 5, 6. It's an even degree, negative leading coefficient. So the arrow goes, and it looks weird, I know, but the arrow goes here and here. So the basic shape is just like this. The last one, I, is degree, nope, there's another one, there's J. So the second before last is degree 4 plus 3, so 7, that's odd, 3 is positive. So it looks like this, an arrow here, an arrow here. Finally, J is the last one. X squared is an even degree, degree 2. It's negative because of the negative 5. And so it looks like this. An arrow here and an arrow here. And we're done. Bring any questions you have to class. We'll talk about them. Good luck. Have a good rest of your weekend. Goodbye.